Welcome to Lesson 5.3, Review of Functions. Let's take a look at our objective for today. I can identify functions and linear and nonlinear relations. So what we're doing is we're taking the two lessons that we did last, one being identifying functions, one being linear and nonlinear relations, and combining them into one review lesson. So flip the page. We have to think to ourselves, what is a function? So remember, we took a look at multiple examples and some non-examples, and in that we found that a function is a relation where every x value is paired with exactly one y. So what that means, I'm going to start over here, is that our x values cannot repeat. So x values cannot repeat. Okay, so make sure we star that x values can't repeat. That's what a function is. Remember, a relation is a set of ordered pairs, right? It's a set of x and y that are together. We have to figure out if these are functions or not. So taking a look, we need to make sure that every x value has one y that goes with it. So I have to see if any of my x values are repeating. And it looks like I have a 2 twice on my list, right? 2 is with 10 and 2 is with 15, so it is not a function. Here, if we look at all of our x values, I'm going to underline them. I have -1, -2, 2, and 4. They are all different, which means it is a function. Okay, looking at the next one, I have a 1 for an x, 2, 3, and 4. Remember, I'm only looking at my x values. It doesn't matter what my y values are. And I notice, yes, it is a function because they are all different. Lastly, I look at my x values again. I have a 0, 2, 4, and 4. So I have 4 and 4 here. So two x values are repeating, so no, it is not a function. So what I want you to do now is look at these three tables and tell me if they're a function or not. Remember, look at the x values and see if any of them are repeating. All right, welcome back. Let's look at these two graphs now. We have this one and this one. Now remember, if an x value can't repeat, that means that we cannot have our function touch any vertical line more than once. If it does, then it is not a function. Right? So remember, the vertical line test means if I can draw a line through my function and it passes through 2 points at least, then I know that it is not a function. So here it does not pass the vertical line test because it points. So it's not a function. Here, this squiggle, no matter where I draw a vertical line, right, it's only going to touch the picture once. So yes, this is a function. All right, flip the page for me. So now what I want you to do is take a moment to do this one for me, asking which table is not a function. So make sure you look for the one that is not, okay? Please raise your hand to get it checked when you're done. All right, now that we've reviewed functions, now let's go back to what it means to be a linear function or a nonlinear function. So remember, a linear function, it has the word line right in it, right? So the linear function is when graphed, it creates a straight line, right? So a linear function is just a function that's when graphed as a line. But remember, y equals mx plus b form is the form that it needs to be in to be a line if it's written out. Okay? Nonlinear function, you got it. It's a function that doesn't graph to be a line, right? So when graphed, it is not a line. So that means it cannot be in y equals mx plus b form. It's going to be something else. Maybe the exponent will be different. Okay, on that x. So flip the page. Let's take a look here. 3 things. It says, is the graph linear or nonlinear, and is it even a function? So remember, every linear function is a function, right? Any line is a function, but let's see these other ones. So here, if I notice, if I draw a vertical line through here, it crosses my picture twice, right? So is it a function? No, it's not a function because it doesn't pass the vertical line test. But even though it's not a function, it is also nonlinear. Okay, so its relation is nonlinear, doesn't create a line, but it's also not a function. Okay. Now here, if we look, we have a line. All lines are functions because if I draw these vertical lines anywhere I want, it will only touch once. So this is a linear function. All right. Looking at this one, I have a horizontal line. Looks like it's a function because no matter where I draw a vertical line, it will only touch that line once. Right? So that I have that it is function and it is a linear. All right, so I want you to take a moment for me, do D, E, and F. Please raise your hand to get it checked. All right, welcome back. Now let's look at some equations and see whether they're linear or not. So remember, if it's linear, it needs to be of the form y equals mx plus b. Okay, which means that the exponent on the x has to be a 1. So looking at this first one, I have y equals 1 over x. X is in my denominator, so it's not going to have an exponent of 1, which means it's going to be not linear. Our x is in the numerator. Well, what does that mean? This is really the same thing as taking y and having it equal to 1/2 of x, right? X over 2 is the same thing as multiplying x by 1/2. Is this linear? Absolutely, which means that y equals x over 2 is linear. 1, I have an exponent of 2. I need it to be an exponent of 1, so it's nonlinear. And here, x is in the numerator. So remember, I can think of this as y equals 1/5 x plus 4. That means that it is linear because it's in this form. So I can write it like that. Okay, what I would like you to do is take a moment for me into these 9 problems. Please raise your hand to get it checked when you are done. All right, welcome back. You have 2 more problems to do. I want you to take a look at both of these. Now, the tricky one with this last one is that our variable here is r instead of x. Don't let that fool you. That's still our variable, and that still needs to have an exponent of 1. Please raise your hand to get it checked when you are done. All right, welcome back. Let's take a look here at these tables. We want to know if the table gives a relationship that's linear or nonlinear. So remember, if it's linear, that means it has a slope. That means that my change in y is the same every time, and that my change in x is also respectively the same every time. If they're different, that means it's not going to be linear. So if we look at this first one, it looks like from 2 to 3, we go up 1. 3 to 4, we go up 1. 4 to 5, we go up 1. Same thing over here, we're going up 1 each time. So because the y's are all the same and the x's are all the same respectively, we know that it is a linear function. Okay. Looking at this next one, we have 2 goes to 4, that's plus 2. 4 goes to 8, that's plus 4. 8 to 16 is plus 8. These are all different. So because they're all different, that means it's not a linear function. Okay? All right, your job is to do this multiple choice question on the bottom as well as this one right here that I've circled for you. Please raise your hand to get them checked when you are done. Thanks, bye.